So today we are going to talk about how we can master cloud-native Java without leaving what we as developers treasure the most, our code. And I assume everyone who came here prefers our beloved IntelliJ idea for Java, and we will see that it could be really helpful when we develop cloud-native Java applications. So a little bit about me. My name is Ivan. I work for Google Cloud Platform, and I work on Cloud Code for IntelliJ, which is a plugin for IntelliJ, and we support VS Code as well, which aims to make a development for Kubernetes and cloud native as easy as if you just were developing on your own local machine within your beloved IntelliJ. But first things first. What is cloud native anyway? There's a lot of buzz going on around it. Is that hard to explain? It is. Requires reading a 100-page book to understand this. Actually, it is not. Let's take a look here. Here is Cloud Native Foundation Charter itself. That's the core of the description of the foundation itself. And it's pretty succinct. It's really laconic and easy to understand. So cloud-native technologies empower organizations and us developers to build and run scalable applications in clouds. And it could be private cloud, on-prem cloud, or public cloud. Oracle Cloud, Google Kubernetes engine in Google Cloud, AWS, of course. So for us developers, what's in red is a little bit more important than everything else. So containers, microservices, and declarative APIs exemplify this approach, along with immutable infrastructure, service meshes, and some other things. So it seems we need to put our applications into containers, potentially run them as a multiple microservices, and use declarative APIs to deploy this into cloud. And an elephant in the room in this cloud-native space is Kubernetes. You need to control Kubernetes with declarative API to run and launch your application in cloud. It's always good to start with a nice little story, so it will not be boring, and I will just talk about abstract stuff. So it's a tale of three developers and the idea. We're here in San Francisco, in Bay Area. Everybody works for a startup, wants to start a startup, maybe thinks about starting a startup. They started a startup. So what is the idea? Brilliant, voting as a cloud service. So we live in democracy. There's a lot of voting and elections going on, right? We heard a lot about Russian hacking to election. I'm from Russia originally, so let's talk about this. They decided to build it really, hardened, really well, 24/7 available. And of course, it needs to be a cloud service. It needs to work in multiple clouds. What could be better than build it in a cloud-native way and work with Kubernetes? Yes, Kubernetes is vendor neutral. You can use any cloud. You can run it on multiple clouds. You can even scale it and share it between multiple clouds. Perfect idea. But let's see. There are three of them. Two of them are Java developers, but one decided to step away a little bit from Java and chose Kotlin. Another one is decided to stay with Java and Spring Boot. And third one, he will help them with JavaScript. He will not be able to use IntelliJ, but WebStorm is not worse than IntelliJ. So they sat down. They were very experienced, just like us, all here in the room, I hope, experienced Java developers and JavaScript, and drafted this perfect, great, very short design. So the traffic will come via IP and domain name into an ingress, which is like a Kubernetes thing to route your traffic into a cluster. And the first thing is front-end service. So that guy who switched to Kotlin decided to use Kotlin. Cater is a server-side framework. Gradle is building this project. So front-end service will serve the root web page where people will cast their votes. And it will also serve results, a static resource where you can see results. When you cast votes, it goes to another microservice, vote service. And where vote service is harder brain of this microservice application, we will keep count of our votes and notification service with a Node.js JavaScript app, which will use wonderful WebSockets to live update results page. So once you voted, you can see how picture, evolves and what's going on with an election. Perfect, great idea. So what they decided to build these three microservices. They opened the IntelliJ, they wrote the nice implementation, they experienced developers. But what's next? Containers. Who is using containers here? Everyone, I guess. Yeah, Docker. Yeah, well, not everyone, but yeah, well, sooner or later you will need them because they're super cool. What is a container? Lightweight virtualization. You can run on your server, on your machine, as much things as you want, I mean, depending on the resources you have, and all of them are isolated. Very cool. But what do we need to do to put our application into a container? Well, first we know if we use Gradle, we can assemble the project, maybe same thing, okay. But then we need to put this into a container. So what is this? It's this command, the standard, pretty standard thing to build and put it into a container. You build it, you use a Docker file, which is assumed to be here in this directory, and then you say, I want to tag it and put it into some container repository. Container repository, something like a Maven repository, you put a container image there, and then Cloud Kubernetes pulls it from there. And you see that thing in the end, highlighted? Do you know what it is? This is supposed to be unique. Containers are immutable, which is great. Every image you build with a unique tag is never modifiable again. So you can reproduce your system. But we'll see what happens next. When you put this image, you push it to a remote repository. Then, potentially, you know a little bit about Kubernetes. You create a deployment, and you say, hey, kube control, apply this deployment, and now Kubernetes running on your cloud cluster will run it. And then you need to understand what's going next. So now we will not have direct access to the application when you run it locally in your IntelliJ. And now it runs in the cloud on Kubernetes. So you use kube control, you get pods to see if they're healthy, you port forward them, and so you can access the endpoint, for example, here, 8080, and then you get logs. So not bad. Let's count. I counted about 8 additional commands and approximately 3 CLI tools and 1 editor to just run your application. Do the same what you do in one click in IntelliJ, but you run in Kubernetes. What happens if I turn ahead like this? What does it look like? It looks like an infinite amount of time to me to pass an application from my IntelliJ IDE to Kubernetes cluster. And don't forget, all of these 8 steps needs to be repeated for all little changes and bug fixes. So you will not spend a lot of time with your code in your business logic. You will spend a lot of time on CLIs and configuration. This is actually not what we want as developers. We want to spend more time with our code. But this is not it. Declarative API is in YAML. So yeah, this is a nice dev process. So it's easy to see, right? We want to code maybe a little bit of kubeconfig and see our application, but in here, we just saw all of these extra steps are not what we actually want. So anyone heard of Kelsey Hightower? So he's a pretty vocal figure in Kubernetes world, evangelizing Kubernetes for quite some time. So it's sometimes better to just quote a famous person. Everything in the world of Kubernetes ends up in a YAML file. Absolutely true. And whole conference about YAMLs. It's called KubeCon. Absolutely true. So we will see a lot of YAML files. I hope you enjoy writing YAMLs from scratch, from zero. Who loves this? No one? OK, I hope someone would write it, and I will call him 10,000x programmer, because I can do that, and most of people I know can do that. But actually, there's an easy way to go with YAMLs. Most of them we write for Kubernetes are pretty standard. Those are just standard deployments. These are just standard services. We just want to start our application in Kubernetes for the start. And we can use IntelliJ live templates to that. And it's just so easy to start with them and very easy to deploy after that. We will see that. So we can solve this. But then next, debugging microservices. Once you have multiple moving pieces inside of a cluster, how do you debug? What happens here in this code in the middle? We use Spring Boot-based REST template, and we do exchange of REST entities, and we call, for example, this notification service, and we get a response. What if something goes wrong? Who is wrong? Who is right? Is this notification service issue? Is this world service issue? Maybe some other moving parts issue. So what could we do? We cannot just debug this locally because it's all running in Kubernetes. So multiple things we can do here. So first things first, unit tests. Of course, we should always do unit tests. So we can spy, stub, mock all of our remote dependencies. But what do we do when we do that? We base it on our assumptions. We only know so much about current state of the service with spy and stub. But what we've changed, what is a very agile process, like in startups, it's always change all the time. And hopefully we move in high speed and they break things all the time. And even if our unit tests pass in cluster, something is failing. What else? Some people use local Kubernetes environments. You can do that on your own laptop and set up and see what's going on in your microservice application. So Minikube, Docker, some people use Compose. Sometimes they think Compose is a little bit better, a little bit easier to set up than a whole Kubernetes environment. But there's a problem with this as well. You only have so much resources on your local machine. Imagine you have tens of microservices, or they're pretty heavy. They have heavy functionality, they need a lot of memory, so you need a large virtual machine to run them. And then you might use wonderful cloud APIs, Cloud ML, Cloud AI, Cloud Speech Recognition, Cloud Vision. Everything like clouds offer so much functionality nowadays, and you will use it no matter what. And when you run it on your local Kubernetes cluster, you will just not have that easy access to those cloud APIs. So finally, it's probably the best and most recommended way to do that. Have development environment, development Kubernetes cluster or a namespace, completely identical to your production. If you heard of 12-factor application, one of the factors is to test and develop in the environment completely identical to your production, which is, again, would be hard to do because you don't have direct access to your development cluster. You need to set up a specific debugging images, to set up a specific debugging ports, port forward them, and do that all manually if you want to connect and debug right on your Kubernetes cluster. So they were pretty frustrated, but they found cloud code for IntelliJ and VS Code. And they figured out all the issues that they saw. 8 additional commands to build containers. Not ability to debug, single-click debugging from an IntelliJ or other IDEs. And all this mess with declarative APIs and YAMLs all could be pretty much solved when you use Cloud Code. So let's see. Cloud Code allows you to build highly scalable cloud-native applications. We integrate a set of tools for you. They will help you to quickly redeploy, rebuild, retag your container images, push them into a cluster. We will allow you to live debug your application on Kubernetes cluster with just one click, as if you were just running your application locally in your IDE. So we give you more time to focus on writing and evolving what matters to you as developers, what matters to that startup developers, what matters to me most as a developer, my code, my business logic, my idea. So now it's demo time. I will impersonate those startup founders, one Kotlin developer, one Java developer, one JavaScript developer, and we will see how hard or how easy it is to put your application to work in Kubernetes in cloud-native way. So just to refresh your memory, this is what we're going to see. First, I'll play the Kotlin developer. This will be a front-end service. It just serves static resources for those 2 pages. Then vote service, the most important part, the brain and heart of this microservice application, Java, Spring Boot, Gradle. And notification service, Node.js application that will just use WebSockets to live update the results page. Sorry. OK, let's start. So first things first, let's go and see how do you get Cloud Code. IntelliJ, preferences, plugins. I already have this plugin installed, so it's Cloud Code is here. But if you don't have it, you just go to Marketplace, and type Cloud Code, and you will find it here. Also, for this demo, I installed the Kubernetes plugin from JetBrains, which is pretty helpful to work with YAMLs, as we will just see in a minute. So this is my code. I'm now a Kotlin developer, and I use Ktor framework. What's good about Kotlin, you can use inline functions to create a domain-specific language. And here, instead of calling some functions on applications, some methods, I just say, hey, this is my routing, this is a static resource, this is a static resource. Beautiful, only a few lines of code, and my web server is ready to serve. And it's working. I can just run it locally from IDE. And so what's next? We will need to create a Docker file. Docker file is that set of instructions to put your application and all of the dependencies into a container, basically just to create its internal file system. So I created this Docker file, and I can say it's pretty terrible because I just copy locally built jar file, and at least I base it on Alpine, not on Ubuntu or some operating system base. But then again, I doubt it's even work, but I'll just copy it from Stack Overflow, right? That's what you do when you don't know something. I'm not sure actually what to do with Docker files. There's tons of documentation on that. Is that supposed to be so hard? We'll see. But now, the YAML, I don't have any YAML here. How do I deploy? This is what I do. I say create, hey, this could be my Kubernetes resources. And now I create my YAML files. I heard you need to create deployment to deploy in Kubernetes. And this is right. This is my deployment YAML file. Yeah, let's add this. So where do I start? It's so complicated, but we have Kubernetes plugin installed. Just use snippets or live templates. If you start with Kubernetes deployment, here is it. 1, 2, 3, it's done. I need to know, well, I'll say it, yeah. This is going to be my front-end service. And you'll see all the labels, everything is created for me automatically. Now the image name. I will use Google Container Repository for my image name. And this is my project. If we use any other cloud, any other image repository, Docker Hub, you just put for Docker Hub your, I think, docker.io/name/container image. So I say, yeah, this is my container image. And that's it. I mean, everybody loves changing replicas because that's the amount of replicas that will support the execution of our code there. And I'll put 3 just to be sure we'll handle all the world's laws when everybody starts using our voting service. So this will run it, but it will not expose the port. So we'll need a service. And again, I'm not going to use my YAML, bad YAML skills. I just use snippets. So everything I need to do is type a file name. And this time, instead of deployment, I say, hey, Kubernetes service for me. Excellent. So I will use the same name. Take different deployments, different object types in Kubernetes have same names, and selector will match that selector of deployment we just created. So we'll use the standard HTTP port. The target port will be the one I used in my application. And type node port is OK, but I just need a cluster IP because I don't need any load balancing for it. So excellent. So what's next? We go to CLIs. We just try to deploy. What do? No, we don't leave our IDE. We go Tools, Cloud Code, Kubernetes, Add Kubernetes Support. 1, 2, 3. What do we see here? We have 2 new run configurations. Kubernetes deploy, Kubernetes continuous deploy. What is the difference? Let's add it and see. So Kubernetes continuous deploy. I hope you can see it well. What it does for you, it's something like quick fix, quick debug mode. It runs continuously, and when it detects changes in your code or your configuration, when you save it, it will automatically tag, push, and redeploy it for you. Forget about changeable version numbers. Forget about pushing into repository. Forget about redeploying, reapplying your Kubernetes configuration. Everything will be done for you. Just add a change, save, it will be redeployed to your Kubernetes cluster with all your Kubernetes manifest. And single deploy is just what it is. The single deploy will just do it once. And let's take logs once we deploy. And for continuous deploy, let's keep deployments when we finish. So I think we're ready to go. But we also need to know what's going on with our Kubernetes cluster. Do I even have it? Maybe I do. Do I need to go to some other dashboard, leave my IDE in code? No, I don't. Here on the right, you see a set of tool windows. And one is this Kubernetes Explorer. So I see a lot of my clusters. So this is clusters. And for some of the clusters, I have 1 context. For some of them, I have 2 contexts. By the way, anyone knows the difference between context and cluster? It's easy. So cluster is actual physical cluster, right? A set of nodes that run your workload. Context is something from world of kube control tool. Context is just a cluster, a way to access this as a user, and a namespace you want to put everything into it. So, for example, for Docker desktop, I have 2 contexts for some reason. I think it's a Docker bug. But now my active context is code 1 on Google Kubernetes engine. Let's take a look if it's actually available. So it shows me my default namespace is what it is, the current namespace in my context, and it will show me that I'm running a thing called Ambassador. This is the thing that will handle our ingress, but nothing from our application yet. Great. So let's try to deploy it and see the logs. So what we see here, well, it's going to be really fast because I apparently built it before. But it's like, yeah, it took like 1 second. But there's an error in there, container terminated, no man manifest, because I think I had a very bad Docker file. I didn't include dependencies, and I just didn't think about much there. Is there a way to do that again? I'm not a Docker file expert. I just want to put my Java application into a container. And there is. Let's see. This is called Jeep. Anyone heard of Jeep before? OK, good. I hope you will like it. So now with Jeep in one turn, you become container experts. You don't have to think about Docker files anymore. Do this. Apply the plugin for Gradle or Maven. And if you want to build a separate image, just do Gradle Jeep or Maven Jeep target. What it does for you, it analyzes your Java project. It splits it into resources, classes, and dependencies. It will never rebuild without need. It will use carefully selected base image. It will build very optimized small container image. And you don't need to do anything. Just include it as a plugin for your project. So let's do that, because Cloud Code supports Jeep as well. I'm going to my Docker file. What should I do with that? And now I need to go into a configuration of Scaffold. Scaffold is the engine behind what Cloud Code does for you at Kubernetes. Why it's good to have something below the IDE. This is a CLI tool. We don't need to touch it from working IDE. But when you want to transfer your deployment debugging sequence into CI/CD pipeline, for example, you can reuse the same Scaffold configuration, which is Scaffold YAML by default, and the same steps as you use in IDE. So your development process is not separated between IDE and CI/CD, and you just use the same process. So everything should match in your IDE and your CI/CD pipeline. So what I have here, I have image built from Docker file. Everything I need to do, I just say Jeep Gradle. It's the Gradle project. And that's it. Hopefully, Jeep will solve this issue for me, and I'll forget about Docker files and everything. OK, it's found cache, tags. Let's see. Wonderful. I see some logs. So logs are streamed for you automatically from your Kubernetes cluster. You don't need to go to CLI and stream logs and just try to find out where are you, especially if you have multiple project windows open. I don't think I see any errors. So it should be good. I also can go into my Kubernetes view and say, hey, refresh pods, and I see my free instances. How about deployment? Was it deployed? Yes, I see front-end service and services. Let's update it. A new front-end service. OK, so this is my domain name, what-k8s.org, that I set up for this voting. Previously, Ambassador told me, like, the ingress component, there's no health upstream, no microservice to handle the address. Let's see that about now. Excellent. I think we just started the front end, but it will not work because the other components needed. Yes, service unavailable. Let's continue. So now we're switching to our Java developer. Good. This deployment is done. So this is, again, the brain and heart of our application. For the simplicity of the demo, we are stateless here. So this, the votes will be kept right here in a hash map. So not really a persistent solution, but it's really easy to understand what's going on here. So this is a simple Spring Boot handler of this mapping, and it should just accumulate votes and notify notification service. So again, it's working. I tested it locally. What do I do to put it into a Kubernetes cluster? First things first, create YAML resources. I already did this. We just saw how to use it with snippets. Exactly the same. I spent maybe 3 seconds creating those YAMLs, never thinking about mistakes, because I just used pretty much standard snippets, and they work maybe, I don't know, 80, 90% of the time. I just used appropriate ports, and the image name is different for that. Excellent. And again, a Docker file. Again, a terrible Docker file. But we already know how we fix this for Java projects. So we go Tools, Cloud Code, Kubernetes, add Kubernetes support. And we see what we want to see. A target in IDE to deploy or just quickly iterate on Kubernetes deployment and the application here. So again, we'll keep the deployments and tail. And how do we use Jeep? We'll go here and say build it with Jeep. All right. in this crust, deploying. And again, I built it before, so that's why it's so quick. But we'll see with the change, it will be so quick as well. And again, we'll see standard Spring Boot logs. Everything's starting. I think everything working so far. Start application, perfect. I'm staying in my IDE again. Do I see me using any CLIs yet? No? No one? No magic? Yeah, I'm just developing and deploying to my Kubernetes, staying in IntelliJ. Nothing extra is needed. Okay, we deployed. Let's go check. We have an Explorer here as well. How about deployments? Do we have it here? Yeah, what service? Excellent. So now we go to our JavaScript guy in Node.js application, here the web storm. So unfortunately for Node.js, there's no alternative like Jeep yet. Maybe it will appear soon. But Dockerfile is a little bit simpler. We just need to copy those package and GS files and then run it from a standard Node image. So we'll use Dockerfile for this. So we need to run and just to start this HTTP server that will communicate with our word service, receive the updated words from it, and notify everyone connected via WebSockets. Again, tools, Cloud Code, Kubernetes, add Kubernetes support. And then again, it's not IntelliJ, it's WebStorm, and the same will be available in PyCharm, Golang, whatever application you want to use. Great, I see my targets. Everything is here. I am deploying to my active context, which is Code 1 and Google Kubernetes Engine. This is my little cluster that I work with. I'll keep my deployments in continuous mode, and I'll tail deployments for now. Let's deploy. Again, it's going to be really quick because I built it before. Let's wait for some logs. Logs, listening. OK, great. We'll listen for that. Again, I didn't leave in IDE or IntelliJ or WebStorm for that. Let's see if we have Kubernetes Explorer here. Yes, so we do. How about services? Do we have this notification service here? We do. We can even stream logs from service or from deployment, just to be sure. Yeah, logs are fine. Everything seems fine here. I can control the overall development process, the picture that works here. Excellent. Where is it? I'm ready to go. I like Cloud Code, Jib, and Scaffold. Is it working? Looks like it's working. Anyone wants to try? Maybe you vote for something else? Yeah, vote. Let me check. Maybe I'll vote from my phone. Let's see. I'll vote for Google Kubernetes Engine. And Scaffold too. What's happening here? I think we have a problem. It looks like there's a bug here. And now the dreadful thing, debugging microservices on remote cluster. Unimaginable. Try to imagine this doing this manually. You don't have access to it. You cannot connect to debug mode. And images that you just deployed, they just can't be run in debug mode. You need to recreate all of your YAMLs, adjust them, use new versions, put your application debug mode, Java tools options, port forwards. It is a lot of work. And after that, be sure to clean that up. It's a lot of tedious work. But look here. Well, first aspect was JavaScript, right? Java is much better. So they say, well, maybe that's a problem with your JavaScript. They say, OK, what do I do? Maybe I put a tons of log messages or redeploy that manually. No, look at this. We got a debug button available right here in your IDE. And this is notify method. And then say, OK, will it work if I just want to debug this? OK, we're connecting, we're listening, and it seems like we're working. Let's see what we get here. If we go and cast another vote. For example, these should have more than one vote. All right, we hit a breakpoint. What happened here? Yeah, timeout, of course. What happened here is just quickly, behind the scenes, we converted your application into debug mode. We changed all the Kubernetes manifests, your application entry point, redeployed it into Kubernetes cluster, and port forwarded that connection to you, to your IntelliJ or WebStorm IDE. Now you have full access to that Google data center, to that application running to the old state you have there. Just do that from your IDE as you would do locally. Everything is here. Perfect. Now, let's see. I'll do that. Yes, I said request body. So what is request body? It's a Cloud Code 1 and Jeep 1. It shouldn't be that little. We should have more. So it seems it's not my problem here in JavaScript, says the JavaScript guy. It seems something is wrong with vote service, which sends the updated information. Okay, is it available for Java? Let's see. Let's go to vote control. And continuous mode. Yes, the debug button is here. So let's see, will we be able to repeat this magic here in Java? We're redeploying. We did a new version. Don't worry. A production version or tag-specific version, nothing will change. Everything stays the same. This is completely separate. It's completely separate image that you just use for debugging. Okay, let's do it again. Yes, now in debug mode it's not responsive. Yes, it's again here. And again, exactly the same for Node.js, exactly the same was done here. We're now looking into the state of things in Google Data Center and Google Cloud. Everything similar could be done for any cloud. AWS, your own on-prem cloud. We're now here inside of the server, inside of the pod and container running on Kubernetes. Let's see. Probably have a votes. Let's vote a little bit more. Okay. So we have some votes here. We have Cloud Code 4 and Jeep 1. Okay. So we're adding them. It seems fine. Let's run to cursor here. And we are running and sending the votes to our notification service. I'm pretty sure I never make bugs. Who made bugs, right? I mean, I never introduced bugs, said the Java Spring Boot guy. And he says, okay, so notification response. What does this notification server response? He said Cloud Code 1. But it just was 4. I think even 5. What's going on here? Anyone knows where the bug is? Maybe? It's hard, right? Well, I know what the bug is. I'm sending new votes instead of accumulated votes here. Yes, and even logging the new votes. All right, I found it. Sorry, my bad, said a Java Spring Boot guy. I hope I fix it. So let's do continuous deploy in case we'll find any more bugs. So continuous deploy again. I will deploy my application, and also the call code will just watch all of my changes and redeploy as I need it. So I'm redeploying. Succeeded? Great. So just changed what I sent to notification service. Instead of new votes, accumulated votes. But I also see the problem here. I'm logging not what's needed to be logged. So say, hey, just log votes, and I do save. What do we see? Again, retagging, new tag version, redeploying, re-updating, everything starts again. I don't need to go and do anything. And I also can always go here and see if everything is fine and stream logs and see if I have enough. I'll see. Excellent. Now we also saw what services because one was going down, one was going up. Now one is left. Fingers crossed. Fingers crossed. How about this? Okay. Better. So you want to help me here? What-Kubernetes? Choose something that you like from a presentation so far. I would like Jeep, excellent. Anyone else? Take out your phone, What-Kubernetes. Oh, Jeep, Cloud Code, wonderful. You know, this voting as a service is not bad. I think they should start selling. It just works. And look what they did. When problem arrived, they didn't spend more than 10 minutes to live debug it on the Kubernetes cluster in a remote data center, looking at an actual problem. Well, probably it's not the way to do it in an election night, but it's definitely a great way to quickly identify problems without leaving your idea. Excellent, thank you. And well, this is just a set of candidates that I chose, but we're here in democracy. How about new candidates? Kotlin, anyone like Kotlin? Want to add Kotlin? Anyone else? There's a lot of talks of GraalVM. What do you think about GraalVM? Good, bad? Let's try it. I hope this will be anonymous voting, right? No one, everybody is very very polite. So let's see. Now, everything isn't just front-end service. I'll go and say continuous deploy. And it should be rolling updated into a new application. So here I have some settings. Yeah, sorry for my copy paste. This will be easier. So let's say Kotlin, maybe you like Kotlin. So let's say, how about GraalVM? And results should show this thing. Where are the results? It's right here. Look at the logs. Everything as I change is rebuilt automatically and deployed. Again, safe. Let's take a look. Oh, okay, it's here. I like Kotlin a little bit more. And then, for the simplicity of the demo again, we haven't used any Redis, Memcache, or whatever it is. Everything was saved in vote service, so our previous voting data is lost. So we need to vote a little bit more again. So I like these things a little bit more than GraalVM. So let's see. Oh, great. So let's see. Maybe Kotlin and GraalVM will be a little bit more popular. I don't know. I'll vote a little bit more. I like Kotlin because we are using Kotlin in development this plugin. Great. Yeah, I agree. Scaffold is good, especially in conjunction with Cloud Code. And in Jeep, you can do it a lot. So yeah, I understand you not using it. Many people not use anything from above, but I definitely recommend start using it. All right. So recap of what we just saw. You can now control everything in your Kubernetes cluster right from your IDE. And again, have I used any CLI tools? Have I switched from my code? Have I went to some web dashboard? No? No magic. So what else can we do with Cloud Code? You can develop in remote cloud on any Kubernetes cluster, just as I mentioned, Kubernetes engine from Google, AWS, Oracle, of course. You can do it on local Kubernetes. What's good about local Kubernetes cluster? It gives you absolutely the same feeling. And it will not allow you to work with it easier than a remote one. You will still need to port forward. You will still need to run everything in debug mode if you want to debug. And with Cloud Code, it's very easy to do that even on a local Kubernetes. We also have profiles. We haven't got enough time to look at that, but you can create custom profiles if you want to custom build your image, maybe include custom Kubernetes resources for that. Container builders with a Docker, Jeep for Java. You can use Docker Hub, GCR.io. You can use Amazon's container registry, everything you know the address, and you have authorization for it. Cluster browsing. You can browse your cluster, stream your logs, describe your resources. You can refresh and create them and view it right from your IDE. Debugging. For now, we have Java and Node.js. It works just like that. And Go and Python is coming soon, hopefully end of this month. Editing. We have a rich YAML support. What we saw was a great functionality from JetBrains Kubernetes plugin. We have a lot more. We have a lot more. Knative, Kustomize, and MO is coming. We'll have Istio, which is a great service mesh, Cloud Build, and we have a lot of support for Google Cloud APIs. And deployment, I show you how you can use continuous deployment for quick fixes, quick updates. You can use manual deployments, just run it once. And also, we support Cloud Build, which is another interesting feature from Google. You can just push all your sources into cloud and build it there. And again, Cloud Code supports it. You don't need to leave your IDE to do that. And just a little disclaimer, the Kubernetes cluster browser, it's already available in VS Code. For IntelliJ, it will come end of this, like probably in 2-3 weeks, we're releasing beta of Cloud Code. So all of that features that you just saw will be available there, plus a little bit more. Which is just exciting release coming in a few weeks. How to get it? IntelliJ, just as I saw, just preferences plugins, go find it on Marketplace. Visual Studio Core, again, same thing. We got GitHub repositories for issues and enhancements. Please, please come file issues. We watch it every day, every hour, any issue that you run into. you want to use it, you find it not helpful, please let us know. We're still in active development. We have a lot of crazy ideas. We would love to hear from you. This is a documentation site. You will find a lot of quick starts and tutorials there. So thank you. Thank you. This is my credentials. This is demo address. And thank you very much. I hope now you know how easy it is to master cloud native in IntelliJ and other JetBrains IDEs with Cloud Code. Thanks.